What's up? I'm Vin, and I'm going to go through the January 2026 Geometry Regents, and I'll leave a link to a copy of this Regents in the description below. Now let's get started. So first I'm going through part 1, the multiple choice, and there's 24 questions here, and each question is worth 2 credits. Question 1, on the set of axes below, triangle RST and its image, triangle R'S''T' are graphed. Which rigid motion is sufficient to prove that triangle RST is congruent to triangle R'S''T'? So for this one here, we just go through the answer choices, and we could go one by one and see which one is going to make this work. So for this one here, what we could do is we could pick a pair of corresponding points and see how to get from one point to the other. So I'm going to start off here with point R, and notice to get to point R' that we're just going to flip over the y-axis. Okay, so first up here, it looks like we have a reflection over the y-axis, and I could see this because it looks like, once again, the triangle that we're starting with here, triangle RST, it looks like each point is just flipping over this axis here. It looks like we have a mirror image. And I could even pick another pair of points here. So we take, let's say, point T, and if I reflect over the y-axis, I go 1, 2, 3, 4 to the left, and then I go another 1, 2, 3, 4. It brings me right to T'. And then the last point here, S on the triangle, we could go 1 to the left, 1 to the left to get to S'. So a reflection over the y-axis is going to be our rigid motion. Now, just in case this phrase doesn't make sense, but this is a very important phrase, a rigid motion is a transformation which preserves distance and angle measure. So when you reflect any shape, the resulting shape is going to be congruent to the original. That doesn't change the size or shape of what you're starting with. Question 2, which regular polygon would carry onto itself after a rotation of 60 degrees about its center? So for this one, it helps to know this formula. And this formula, we could call this the minimum degrees. I'll just abbreviate. Oh, actually, I'll just write it out. The minimum degrees of rotation. Okay, so the minimum degrees of rotation is equal to 360 degrees divided by n, where n is the number of sides. Okay, so the number of sides, and this works for regular polygons, okay, not for all polygons. Regular polygons are polygons where all sides are equal in the shape and all inside angles are equal in the shape. So here, the math that I'm thinking about is 360 divided by n equals 60. And for this one, there's a nice little bit of algebra we could do here just so it doesn't get too complicated. When you have a fraction like this equals a whole number like this, or a whole term, my coworker nicknamed this the swap. Okay, so you could just swap these two and say that n is equal to 360 divided by 60. So n is equal to 6. And this would tell us, okay, which regular polygon has 6 sides? That would be a hexagon. Okay, a pentagon, we would get n equals 5. Octagon would be n equals 8. And a decagon would be n equals 10. All right, a little bit more into the concept though, if you're just still not convinced by this, like what's going on. So I'll just do my best here to draw something resembling a regular hexagon here. So 6 sides, but just know in a circle, we have 360 degrees. So just imagine here that I'll draw this in a different color, that we have a circle going all the way around this hexagon, and the hexagon is inscribed inside the circle. Okay, that means all 6 points are touching the circle like this. So what I'm doing is I'm treating the center as the location of my central angles. And when I do 360 divided by 6 and I get 60, this just tells me that if I were to draw in all these lines like this, that all of my central angles out of the 6 that I'm making here would all be 60 degrees. And that's why a rotation of 60 degrees, see how if I rotated 60 degrees, let's say I'm going this way clockwise, a 60-degree rotation would send this point to this one over here. It would send this one to this one over here. It would map onto itself nicely here. Okay, all these angles that I'm dotting like this are all 60-degree angles. Question 3, the right triangle below is continuously rotated about the 4 centimeter side. The solid formed is, and for this one here, we just have to imagine what it means to spin something. Okay, so here, we have to just be mindful that we are rotating about the 4 centimeter side. Okay, so just over here, this is going to be our axis of revolution. Okay, so just imagine here this triangle is spinning around this side like this. And what shape would we be looking at? We would be looking at a cone. Okay, so the cone, I'm just going to draw out, would look something like this. Okay, so here is our cone, but the side that we're spinning over here, or the side that we're spinning around over here, would go right down to the center like this. Okay, so if I just make this here more pronounced, so this side here that we're spinning around would represent the height of our cone. Okay, the radius would be 7 centimeters. Okay, so if I just draw that triangle one more time, the 7 centimeters would go here, and the 4 centimeters would go here, and then the right angles over here. So here's the triangle as a part of the 3D solid here, but once again, as we spin, this is going to form a cone. The cone is going to have a radius of 7 centimeters and a height of 4 centimeters. So these questions here are just very visual. You can either draw them or just really try to develop your imagination. So definitely not a pyramid, because when you're rotating, a pyramid is not round. It's just, if I draw a pyramid like this, you could see that there's nothing round about a pyramid. Not my best artwork, but that's the idea. But a cone has, like circular qualities to it when we look at the outside. So the last part, once again, that we have to be able to distinguish here is we have to be able to distinguish, well, they both here say height of 4 centimeters. So that was polite that they didn't say height 7 and let's say radius 4 as a trap. But here we have to know that 7 centimeters represents the radius, not 14. Okay, so this one here is out. And it's got to be this one. And the reason why this radius wouldn't be 14 is because that would go from one end all the way to the other end. That would be the diameter of the bottom here. If we look at the circle at the bottom, that would count as the diameter, not the radius. So the radius is going to be 7 centimeters, definitely choice 1. Question 4, in isosceles triangle AHP below, AH is congruent to PH, and AH is extended through H to C. If the measure of angle A equals 2x plus 12 degrees, and the measure of angle P equals 3x minus 8 degrees, what is the measure of angle CHP? So for this question here, there's a lot going on. And the first thing I would do, though, is just label what they give you. They told us we have an isosceles triangle, and they told us AH is congruent to PH. And then they told us later over here, the measure of angle A is 2x plus 12 degrees. So I'll write 2x plus 12 here, and measure of angle P is 3x minus 8. So we have these two angles, and we want to know what is the measure of this angle here on the outside, okay? The measure of angle CHP. So our goal is to find this. Well, an important detail here is that when you have an isosceles triangle, the isosceles triangle theorem says that the angles across from the congruent sides are also congruent. So that means these two angles, angle A and angle P, have to be equal, which means in terms of algebra that we could set 3x minus 8 equal to 2x plus 12. So now I'll just start here by solving for x. So we're going to go plus 8 on both sides. And that's going to give us, we're going to have just 3x on the left, and then 2x plus 12 plus 8 is 20. That's going to be on the right side. And now I just subtract 2x on both sides. And on the right side, 2x minus 2x cancels. 3x minus 2x is 1x, or I could just say x is going to equal 20. But the question is asking us to find the measure of angle CHP on the outside. So the first thing we should do is plug in the value of x to find what the missing angles are. So let's go ahead and do that. So the measure of angle A is now equal to, I'm going to say 2 times 20 plus 12. And we're talking about the measure of angle A in degrees. Okay, so I'll just make that a little neater. This is going to be in degrees. So that's going to give us 2 times 20 is 40, and 40 plus 12 is 52. So the measure of angle A is going to be 52 degrees. So this tells us, once again, this angle here is 52 degrees, but like I said before, these two angles at the bottom are equal. So that means the measure of angle P has to also be 52 degrees. And we could even check. 3 times 20 is 60, and 60 minus 8 is also 52 degrees. So now from here, there's a nice way we could get right to the answer. We could use the exterior angles theorem, which says that the exterior angle of a triangle is equal to the sum of the two remote interior angles, which means the angles that are far away from the outside angle, not the one next to it. So for the question here, I want to find the measure of angle CHP. I could just do 52 degrees plus 52 degrees, which is going to give us 104 degrees, and that's going to give us choice 3. Now, let's say you forget the exterior angles theorem. You're like, oh no, I don't know that theorem. Well, what you would do instead then is you would solve for the measure of this angle over here. So I'm just going to put the letter y over here like this. And you'd have to know that in any triangle, the sum of the interior angles is 180 degrees. So if I use that idea, I could say 52, well, I'll just say it like this, 52 plus y has to equal 180, which still gives us 104 plus y equals 180. And then I subtract 104 on both sides, and that's going to tell me what y is. Okay, so y is going to be equal to, I would say, well, we just subtract 180 minus 104 is 76. So that means this angle here on the inside, so let me just get y out of the way, is 76 degrees. But if this angle is 76 degrees over here and we have a straight line, I could just do 180 minus 76 to get 104, and you can see this is still 104 degrees. But the exterior angles theorem is just, the express way right to the answer. We're getting choice 3. Question 5, in the diagram below, triangle XYZ is the image of triangle ABC after a dilation of scale factor 1/2. Which point must be the center of dilation? So for a question like this, I like to go back to the concept of what a dilation is. So when I hear dilation, I just think of the diagram, the drawing of what a dilation is. So that's when we have a center of dilation and a scale factor. And the way the center and scale factor work together is when I have something like, let's say, scale factor 2. What that does is it takes any point on a shape. Let's say we have a triangle, because that's easy to visualize and work with here. What we do is we take the distance from the center to all of the points that we're dilating, and we just double, in this case double because we have k equals 2, we double the distance between them. So what I do is I connect a line from the center to the points of the triangle, and then once again, if k were equal to 2, I would just take the distance here and just double it and draw my next point out here. The distance over here is a little longer, so I would bump it to about here. And then this one over here, I would bump to about here. And notice when I draw in my new line segments here, that my resulting shape here is another triangle, and the lengths of the sides are all double the one we started with. So when I'm doing a question like this, I just like to do the process, but backwards. So in this case here, I started with the purple, and I'm calling this one the image. And if I want to find my center of dilation, I just think about which points are corresponding. So here we have triangle XYZ is the image of triangle ABC. That means X and A have to be corresponding. So these, I would just extend a line segment here in this direction. And I could just keep going as far as I want, but let's say I just stop it here. And then I would draw a line segment connecting Y and B. So Y and B I'm going to connect. So I'll start over here, and I'm going to draw it like this, going in this direction. And I can already see where our center of dilation is going to be. It has to be where these lines all meet, and they're going to meet over here at 2, -1. But let's just see what happens when I do the last one. So if I connect, we have Z and C are the corresponding points. So if I connect C to Z and I continue, notice that all 3 of these lines are meeting at 2, -1. So choice 1 is definitely our answer. Question 6, in a right triangle, the acute angles have the relationship cosine of 5x plus 7 degrees equals sine of 3x plus 3 degrees. Which equation is always true? So for this one, we have to understand the idea of cofunctions. Okay, this is the big idea for a question like this. And the way that we want to approach this question is we want to know the idea that if A and B, so if A and B are acute, so if these A and B are acute, I'll say angles, and we're told that sine of A equals cosine of B, then the conclusion we could draw here is that A and B have to be complementary, which means when we add them together, the sum of those angles has to equal 90 degrees. Okay, so I'll just say that A plus B has to equal 90. So look here, we could see that the angle inside of cosine is 5x plus 7. So that means this angle here, 5x plus 7 degrees, when we add that to the other angle in the sine function here, so when we add it with 3x plus 3, that result, let me just make this neater, has to equal 90. Okay, this sum has to work out to 90. And when I scan the answer choices, this matches up with choice 2. The $1 million phrase in this question, notice they had to tell us that we're in a right triangle and that the acute angles have the relationship that they gave us here. Okay, so if they don't say acute angles, then we can't use this idea. But for the geometry regions, trigonometry, we're staying inside of right triangles for all of trigonometry when we are at the geometry regions. The only time we're really using trig outside of a right triangle is when we're finding the area of a triangle using the area of a triangle trig formula. Okay, but for the cofunctions question, we're in a right triangle, so definitely choice 2. Question 7, in the diagram below, circle O has a radius of 8 centimeters and a central angle that measures 140 degrees. What is the length of arc AB to the nearest centimeter? So for this question here, first we have to understand what we're even trying to find. We're trying to find the length of arc AB, which is this portion of the circle here, okay, on the circumference of the circle. So for this question here, we should start with the formula that the circumference of a circle is equal to 2 pi r. I could also say circumference equals pi times diameter because 2 times the radius is equal to the diameter. But since we're given the radius in this question, I would prefer to use this formula here. Okay, so I'm going to start off by finding the circumference of the entire circle, which would be 2 times pi times 8 centimeters. And I'll leave the units out because the answer choices don't have units. So 2 times pi times 8 is equal to 16 pi. But now we have to think about this. We're not looking at the entire circumference. We're taking a fraction of the circumference. And the way we determine how much to take is based on the central angle. So here we are taking the entire circumference, 16 pi, and we're just taking a fraction of that. We're taking 140 out of 360, okay, because full spin is 360 degrees, but we're only going up to 140 degrees, so we're taking that much of the circumference. And now all we have to do is just work this out in the calculator. So we could just type this in. We have 16 pi. I could press second, and then this button over here, the up arrow, and then I'm multiplying by, if you have a newer calculator, you could press alpha x to pull up a blank fraction. Otherwise, you could press alpha y equals enter if you just have any TI-84 plus CE. And then I just write in 140 over 360. And they're telling us here to round to the nearest whole number. All right, nearest centimeter, we're rounding to the nearest whole number. So we look at the ones place is a 9. To the right is a 5, so we're going to round 19 up to 20. So to the nearest centimeter, the length of arc AB is 20 centimeters. Question 8, Lucy wants to use a wagon to move a pile of sand in as few trips as possible. The pile of sand can be modeled by a cone as shown below. The height and radius of the sand pile are both 3.5 feet. If the wagon holds 5 cubic feet of sand, what is the fewest number of trips Lucy needs to make to move the entire pile of sand? So for this question here, first we should look for some keywords. The pile of sand can be modeled by a cone. Okay, so we could model this here with a cone. And if we go to the back of the regions, we can see the formula. The volume of a cone is 1/3 pi r squared times h, where r is the radius of the cone and h is the height of the cone. So here, what we should note is that the radius and height, the height and radius are both 3.5 feet. So that allows us next to say that the volume is 1/3 pi times the radius squared, and the radius is 3.5 feet times the height is 3.5 feet. Now, in the Regents, especially when you're in the free response, you actually don't have to write the units in. So if you want to leave this part out, you can. However, I like to show the substitution with the units because we can then understand how the units are going to be canceling out when we actually do the math later. Okay, so, but once again, at the Geometry Regents, you do not lose points for not writing units in your free response answers. But for subjects like physics, then writing the units matters big time. So I will show this just for instructional purposes, but you can make that decision at the Regents to not write units. Because if you don't write it, you could still get full credit. But if you write it and you write the units wrong, then you lose points. So let's type this in. We have 1/3. I'll do alpha y equals enter. So we have 1/3. Hit the right arrow to get out of the fraction times pi. So I have second. And then I hit the up arrow here. And then I'm going to multiply by, so I have parentheses, 3.5 squared. And then I'm multiplying again by 3.5. And then this is going to give us the volume of sand in cubic feet. But now just to finish all the calculator work here, we're told that Lucy's wagon holds 5 cubic feet of sand. So I'm just going to divide by 5, and that'll tell us how many trips that Lucy needs to make to move the entire pile of sand. So the volume, I'll just round this here at, let's say, the third decimal place, is going to be 44.899. And then when I do, let me just make this a little neater, so 899. When I do feet squared times feet to the first, that gives me feet to the third power, which is cubic feet, okay? And notice they said that the wagon holds 5 cubic feet of sand, okay? So that's why when we divide by 5 cubic feet, the units cancel, just telling us how many wagon trips Lucy needs to make, okay? So then we, once again, take this value here, the 44.899, and we divide by 5, and that gives us somewhere in the neighborhood of 8.9. Now, I know this would round up to 9, so let's say I go with, so I'll just say approximately 8.98. But they said, what is the fewest number of trips Lucy needs to make? She's not going to make a fraction of a trip. She's going to need to make 9 full trips here. So even though she doesn't get a full wagon on the last one here, she's just a little short of having the wagon full up to 5 cubic feet. It's still going to take her a 9th trip. So this is we're just going to round here to 9, and that's going to work out to choice 4. Question 9, in the diagram below, BD and AE intersect at C, and AB and DE are drawn. If AB is parallel to DE, which statement is not always true? So for this one, let's think about what we could say once we know that AB is parallel to DE. Well, what I look for, I think back to the beginning of the school year when you learn parallel lines cut by a transversal. When you have parallel lines cut by a transversal, you learn that corresponding angles are congruent, but you also learn that the alternate interior angles formed are congruent. So I could say that these angles here are congruent. And what I look for is I look for the Z shape over here. Okay, so almost like the letter Z, that's what I look for. But the key is you have to be told that the lines forming the alternate interior angles are parallel. Then you could say the angles are congruent. So since they told us that AB is parallel to DE, if we look for this Z shape here, we could see that angle B has to be congruent to angle D. And if I use the other transversal over here, I could say next that angle A has to be congruent to angle E over here. But then to make this a little bit extra tricky, notice that they name the angles with 3 letters, not 1, because they're testing you on your ability to name angles with 3 letters. So angle ABC, you see how that's this one over here? So we have angle ABC is congruent to angle EDC. That one is always true because we were told that we have parallel lines here. So choice 1 is out. That one is always true. Angle ACB is congruent to angle ECD. Well, when we have line segments that intersect, we're told that BD and AE intersect at C. That will always form congruent vertical angles. Okay, so 2 is always true because of this information here. When you have intersecting lines or line segments, the vertical angles formed are congruent, and those are the angles that are across from each other. And then next, is it always true that triangle ABC will be similar to triangle EDC? Well, if all 3 pairs of corresponding angles are congruent, then these 2 triangles here will always be similar. Okay, so this is true. I could use just, this is going to be always true by angle. Okay, yes, technically we did show that all 3 pairs of angles are the same, but I only have to show up to 2. So then just by process of elimination, the last one here has to be the answer, but let's see what it's saying. Triangle ABC is always going to be congruent to triangle EDC. Well, at no point did they mention that any pairs of corresponding sides are actually congruent. So angle does not prove triangles congruent. It proves them similar. So what we could look at here is if I drew things a little bit different like this. So let's say I still am forced to draw my segments here parallel. So I'm doing this as best as I can. I'll say A is here and B is here. And then we have D and E. And notice that I did draw these so that these are still parallel. But I made this one significantly or somewhat shorter than this one. So now when I connect, I go crisscross here like this. See how all the other information is still true. So I could still say here that this angle and this angle are the same. And I could say that this angle and this angle are the same because of the alternate interior angles theorem. So these, all three pairs of corresponding angles are definitely going to be congruent. And let me just name this over here, point C. And the two triangles are similar, but it's clear that they're not congruent. Okay, this one here is smaller than this one. So that's why 4 is not always true. Question 10, the face of a shed is modeled below. The rectangular section of the face BFGK is 10 feet wide. The triangular section of the face FEG is an isosceles triangle with vertex angle FEG and a height of 6 feet. And we want to know what is the measure of angle EGD to the nearest degree. So first let's look at what we're trying to find here. We're trying to find the measure of this angle over here, EGD. And what we know is we know that this shape over here is a rectangle. So we have BFGK is a rectangle. And this triangle here is isosceles. And they said the vertex angle is FEG. So that means these two sides here are the same. And then these would be the base angles, which are going to be equal to each other. But what this then tells us here is that these two triangles here, so I'll highlight them. So this triangle here is going to be congruent to this triangle over here, because when you have an isosceles triangle and you drop down the altitude from the vertex angle, it makes two congruent triangles over here. So if this bottom side here is 10, this tells me that each of these sides is equal to 5. So now when we're looking for the measure of this angle over here in this corner, what I think of is just this triangle on its own separate. So if I have 6, 5, and I'm trying to look for this side over here, I'm sorry, this angle over here, X, then what I could do is I could use trigonometry. So I could say, all right, across from X is the opposite side. And next to X over here is the adjacent side. Now this part here would represent the hypotenuse, but since I know the opposite and the adjacent, I think of the phrase SOHCAHTOA, and this tells me to use the tangent function. So I could say tangent of X equals opposite over adjacent. I could say 6 over 5. So yeah, when you're using the trig functions, just remember O stands for opposite, A stands for adjacent, H stands for hypotenuse. And when you do one of the trig functions, you plug the angle in and you set up a ratio of the sides. And for tangent, you set up the ratio of the side opposite of the angle over the side adjacent to the angle. But now to solve for X here, I do the opposite of tangent, which is tangent inverse. And I plug in the ratio 6 over 5, and this will tell us what the angle is. So we're doing second tangent, and then we're typing in the fraction 6 over 5. And now we press enter, and we're going to get 50 degrees. So we get X equals 50, and this tells us that the measure of angle EGD to the nearest degree is 50 degrees, so choice 3. Question 11, triangles ABC, A prime, B prime, C prime, and A double prime, B double prime, C double prime are graphed on the set of axes below. Which sequence of transformations maps triangle ABC onto triangle A prime, B prime, C prime, and then maps triangle A prime, B prime, C prime onto triangle A double prime, B double prime, C double prime? So for this one here, let's just think about how do we go from first triangle ABC, so this triangle over here, how do we go from this triangle to triangle A prime, B prime, C prime? And notice that this triangle here, we just slide over like this. And anytime you're just sliding the shape over, that would tell you that you're doing a translation. Okay, so here we could start by saying that we're doing a translation first. So that means we could eliminate choices 2 and 3 because we have to start with the translation first. But now we have to think about how do we get from this triangle over to this one? So we have to decide between a rotation or a line reflection. Well, from here, there's a few ways we could go, but let's think about how would you get from this point over here to this point over here. Notice that we would be rotating 180 degrees about the origin. So that would be one way to get from A prime to A double prime. Now, we could also look here and say, well, what about if I reflect over the line y equals x? that would also get a prime to a double prime. However, if we went to do a line reflection over that same line of this point here, C prime, that would send us, so I could see here that if we go, it's going to send us somewhere in this neighborhood over here. See if we reflect over that line, which would miss C double prime. So the line reflection here is not looking good, and choice 1 is looking even better. But now, what we could do to be 100% sure here is we could take the coordinates of A prime, and let's say for this one here, we are at 2, -2. And if we rotate 180 degrees, and I'm going about the origin 0, 0, if we do this rotation here, let's see where we land. Well, the rule is when we rotate 180, we just change the signs of x and y. So that would send us to the point -2, +2, which brings us to a double prime. If I look at the point over here, B prime, so that's over 1, 2, 3, 4, 5, and down 1, 2, 3, 4, 5, 6. So that's the point. So B prime is at 5, -6. That would send us to B double prime is located at, we would have -5, +6. And if we look, if I go to the left, 1, 2, 3, 4, 5, up 1, 2, 3, 4, 5, 6, you see how this transformation rule, rotating 180 degrees, is working, and it will also work to send C prime to C double prime. So definitely choice 1. Question 12, a line contains the points -1, -4, and 3, -1. An equation of a line perpendicular to this line is, and we have these 4 options to choose from. So my thought process for a question like this is, I'm thinking if I'm looking for a line that is perpendicular to another line, I know the idea that slopes of perpendicular lines, so slopes of perpendicular lines are opposite reciprocals. Okay, so are opposite reciprocals of each other. Okay, so this is the real big idea that we need. So if I don't actually, draw this out or anything, I'm just looking at a line that contains these 2 points here. I could find the slope between those 2 points by using the slope formula. So I could start off by saying, okay, my slope is going to be, and let's say I call this point here x1, y1, and I call this point over here x2, y2. So I do y2, which is -1, minus y1 is -4, divided by x2 is 3, minus x1 is -1. And this works out to -1 plus 4 over, we have 3 plus 1. Remember, anytime you subtract a negative, you could just change the operation to addition like this. And now we're going to get a fraction here of 3 over 4. Okay, if I do -1 plus 4, or 4 minus 1, I get 3, and 3 plus 1 is 4. So I have to think about, what does it mean for 2 numbers to be opposite reciprocals of each other? So this tells us that our perpendicular slope is going to be the opposite reciprocal of 3/4. So reciprocal means flip, and opposite means change the sign of the number. So if we have a positive slope here, we're going to have a negative slope over here. So we're looking for an answer choice that has a slope of -4/3, and that's going to be choice 4 over here. Now, if you don't recognize that formula, there's 2 ways to write the equation of a line. You could use the equation y equals mx plus b, and this is when you have the slope and the y-intercept. Or you could use the point slope form equation of a line, which is y minus y1 equals m times x minus x1, where x1, y1 is just some point that's on your line. But notice the slope goes here in front of x minus x1. So the perpendicular slope that we need is -4/3, which would go in this location over here. So you see where the m is? We need -4/3 to go there, and that's where it shows up over here. Question 13, in the diagram below of right triangles DAY and NIT, AD equals 6, DY equals 6, IT equals 16, and triangle DAY is similar to triangle NIT. The length of TN is, and we have these 4 options to choose from. So for this question here, we just really have to know what's going on with similar triangles. So there's a few ways that we could do this, but one way would be to find the missing side over here for AY. So we know these 2 sides here, we could use Pythagorean theorem, and we could say, let's say I put an x over here like this. We could say 6 squared plus 6 squared is equal to x squared. And this is going to give us 36 plus 36 equals x squared, which gives us 72 equals x squared. And now we could solve for x. So we could go square root on both sides, and let's just make this a little bit neater. So we're going to have x squared. I'm going to take the square root of both sides like this. and that's going to give us x equals the square root of 72. But I want to simplify this square root here. So instead of square root 72, I'm going to write this as the square root of 36 times 2. And I know that 36 goes into 72 because we just did 36 plus 36 equals 72. So that would be 36 times 2. And now I could break this radical up to square root 36 times square root 2. Remember, back to algebra 1, you have this nice formula. Square root of AB equals square root A times square root B, as long as A is greater than or equal to 0 and B is greater than or equal to 0. And then now I get that x equals the square root of 36 is 6, and then I get square root 2 like this. So I could replace that x with 6 square root 32. And let's just clean that up a bit. So this piece here, I'm just going to write, we're going to have 6 square root 2. So now we have enough information here to start getting through this question. So what I notice here is that we have corresponding sides now. So I know here that we have 6 square root 2 corresponds to 16 because we're told that these two triangles here are similar, and AY is the hypotenuse of the small triangle and IT is the hypotenuse of the big triangle. So those two sides are corresponding, which means I could say that 6 square root 2 times some scale factor k is equal to 16. And let me just move this over here so I could say, once again, that this product is true. That 6 square root 2 times some scale factor k equals this. And now just divide both sides by 6 square root 2. So I do this. And now I have k equals 16 over 6 square root 2. So when I want to look for what is the length of Tn, so now for this side here, maybe I'll just put the letter y. I know that these two segments here are going to be the same because if these two sides are the same over here, then these two over here I could just say are y and y like this. So what I could do is I could say, all right, well, 6, one of these sides, so the corresponding sides here, I'm looking for the length of Tn. So I could say that corresponds to side yd over here. And I could say that 6 times that same scale factor. So 6 times 16 over 6 square root 2, this is also going to give me the value of y over here like this. Okay, so once you find the scale factor, you can multiply all the corresponding sides by that scale factor to find what you need. And now notice when I work this out, I have 6 divided by 6 just cancels out, and I get y equals 16 over square root 2. But now what I could do is I could make the denominators match up. Now let's say at this point here, or even at this point, you're like, whoa, this is way too difficult. You can use a calculator at this step to get the decimal value and then just type in all of the answers. But let's say you want to go through the actual algebra. What you could do is multiply the numerator and denominator by square root 2. And now this is going to give you y equals 16 square root 2 on top. I'm just doing 16 times square root 2. And then square root 2 times square root 2 is just 2. And when I do 16 divided by 2, that's 8 square root 2. So choice 2 would be our answer. But let's say you're looking at that algebra and you're just like, no way, that's way too difficult. You could do 6 times and then do alpha y equals enter to pull up a blank fraction, and then write 16 divided by 6 square root 2. So let's say we get to this step and we're just like, all right, this is the best that I could do here. Well, from this step here, you just press enter, and then you'd have to run through all of the answer choices. And by the time you get to 8 square root 2, you'll see that the decimals match here, and choice 2 would definitely be our answer. Now, let's say the similar triangle stuff for this question was way too stressful. What you could also do, I'll just draw this triangle separately over here, is you could say, all right, for triangle, we have triangle NIT. So for this triangle, we were told that this side is 16. And we were told over here in this triangle that both sides were the same. So that means these two sides have to be the same, which means that the remaining angles over here would have to be 90 divided by 2, or 45 degrees each. So these two angles would be 45 degrees. So if I want to find what is the length of NT, and now let's say I put the letter Y over here, I could also use trigonometry. So I could say, all right, I'm going to target this angle here, the 45 degree angle, and say that I'm going to do, all right, y over here is adjacent to this 45 degree angle, and 16 is the hypotenuse. And then when I say adjacent hypotenuse, I think SOHCAHTOA. And for this one, I'm like, oh, that's cosine. So cosine of 45 degrees equals the adjacent side is y over the hypotenuse is 16. Now, later on, well, you could also learn this in geometry. Cosine of 45, a nice little side note, is equal to square root 2 over 2. So when I get this information here, like that's another way to just get right to the answer. But let's say, that information is just not known to you. You don't have those ratios, understood or memorized. What you could do is just say cosine 45 over 1, cross multiply, and you get y equals 16 cosine 45. And if you work out the decimal value of this, it's going to match choice 2. If you really want to reach, nirvana here and, learn this for enlightenment, once again, this is 16 times cosine of 45 is square root 2 over 2. And then 16 divided by 2 is 8. So you still get 8 square root 2, which lines up with choice 2. Question 14, the volume of a sphere is 333 cubic centimeters. To the nearest tenth of a centimeter, the diameter of the sphere is, and we have these 4 options to choose from. So the first thing we should do is go to the back of the Regents and get this formula. Volume equals 4/3 pi r cubed. And this is the formula for the volume of a sphere. But what makes this question a little bit tricky is we're told the volume and we have to solve for the diameter. So we're not going to plug in this number here for r. We're going to plug it in for v. So we're going to say 333 equals 4/3 pi r cubed. And now what we're going to do is we have to get r by itself. We're going to divide both sides by 4/3 pi to start. Okay, so we divide both sides by 4/3 pi. And then we're going to have all these terms cancel out on the right side. But then here we're going to get r to the third power equals this number. And then after we get r to the third, we're going to take the cube root of both sides. So let's type this in. We do alpha y equals enter, or if you have one of these newer calculators, you can press alpha x. And we've got 333. And then in the denominator, I could do another fraction and say 4/3. And then hit the right arrow to get out. And then I hit the pi button is second, and then this little up button here. And that gives us r to the third power. But now from here, I have to take the cube root of this. So if I want to do the cube root, I could press math. I could go to option 4 where we have a 3 in front of the radical. Or I could even go to option 5, and that allows you to make a custom radical, and I put the root in front. So we're doing the cube root. So we put a 3 here, and then I have that number from before. I just go up and press enter, and it'll type it in for us. And we get this is our radius. However, just be very careful here. Choice 1 is a very dangerous bear trap. Imagine doing all this work and getting the question wrong. The diameter is 2 times the length of the radius. So at the end, we would just have to double that number by 2. Remember, this is the radius. So to get the diameter, we would have to multiply that radius by 2. So we're just going to press times 2 here. And this is going to give us the diameter to the nearest tenth is 8.6. So I'll just make a little space here. We had r to the third. So up to this step here, we had 79 and then we have 497. And then I'll just round this part here to a 9. And then we took the cube root of both sides. So cube root of r to the third equals cube root of this number here. So 79.4979. And this value here, when we work this out, r equals to the nearest tenth, 4.3. And then from here, we just double this. The diameter is equal to 8.6. Okay, so this part here is where students get a little bit thrown off. When you want to do the opposite of power 3, you're doing the cube root. If for some reason we had some variable to the 4th power, we would do the 4th root of both sides to solve. Okay, and then just don't forget to do times 2 at the end, and you're going to get choice 3. Question 15, line BTS is parallel to line MAVR as shown in the diagram below, and AE is perpendicular to TV. If the measure of angle STE is 38 degrees, what is the measure of angle VAE? So what we start with here is we have these two lines are parallel, and then we're told that AE is perpendicular to TV. So I could say that we have a right angle over here. Then we're also told the measure of angle STE is 38 degrees. And we want to know what is the measure of angle VAE. So we want to know what's the measure of this angle over here. I'll just put an X. So when they tell you parallel lines, that usually means you're either going to use corresponding angles, alternate interior angles. And if I'm looking for alternate interior angles, I'm looking for a Z shape. So you can see over here that we get, even though it's a backwards Z, but we're going this way, we get that Z-like shape over here, which tells us this angle down here is 38 degrees. Okay, so just remember, anytime you have parallel lines cut by a transversal, the alternate interior angles formed are congruent. So these show up everywhere when you have parallel lines cut by, another line. So now we have enough information to solve for x, because we have this angle over here as a right angle. So that means it's 90 degrees. And then we have 38 and x. So what I could do is I could add all three and set that sum equal to 180. Or I could say the sum of these two angles, x and 38, these two values here are going to make 90. And then just subtract 38 on both sides. And this is going to give us, we're going to have x is equal to 52. Okay, so 52 degrees, choice 2 would be our answer. Question 16, segment RAS has endpoints with coordinates r 6, 6 and z negative 12, negative 3. If A divides RZ such that the ratio of RA to AZ is 5 to 4, then the coordinates of A are, and we have these four options to choose from. So there's a few different ways you could do this question, but one would be to just use the formula. We could say x equals x1 plus, and then we say p over p plus q times x2 minus x1. And p and q represents the parts of the ratio. So I would say p is equal to 5 and q is equal to 4. So what I do is, if I'm going for segment RZ, then r over here I could call my x1, y1, and then z would be my x2, y2. And I could start this by just using the formula. I could say x equals x1 is 6, and then I have plus p over p plus q. So that's 5 over 5 plus 4. So see, I'm doing the first value over 5 plus 4 times x2 minus x1. So I have negative 12 minus 6. And that's going to give us 6 plus, we have 5 ninths of negative 12 minus 6 is negative 18. And then from here, I could just divide 18 over 9 is 2. So this gives us, we're going to have 6, and then plus 5 times negative 2 is minus 10. And when we do 6 minus 10, we're going to get negative 4. So our x value should be negative 4, which tells us 16 should be choice 4, because that's the only one where this shows up. But this formula could be tricky to remember. And the key is, though, is actually understanding why it works. And that's why I put the graph paper here, because I'm actually going to just draw this out. Okay, so I'm going to draw out, and let me just move this segment over, because we're going to be going to the left 12. So I want to give a little more space to the left here. So I'm going to draw out an XY axis like this, and we'll do this a visual way. So the visual way is I plot 6, 6. So that's over 1, 2, 3, 4, 5, 6, up 1, 2, 3, 4, 5, 6. So that's where R is over here at the point 6, 6. And then, so I'll just label here, we have 6, and then 6 this way. And then negative 12, so I'm going to the left 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then down 1, 2, 3. So this is the location of Z. So the visual way is tricky, because when the numbers are really far away from each other, it could be a little, difficult to do. So what I do is I count the rise over the run. But if I'm going from negative, well, I'm going here like left 12, down 3. If I'm going from a height of negative 3 to positive 6, that means there's a space of 9 here. And then if I'm going from negative 12 to positive 6, that's a horizontal space of 18. But one thing for this is called directed line segments. If they're saying segment RZ, then I should go from R to Z like this. So I have to say, all right, what is my rise over run? So here, if I'm going from 6 to negative 3, that means I'm going down 9. See, I'm going down 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm going to the left 12. Okay, I'm sorry, I'm going to the left 18. So I'm here, and I'm going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I'm going to the left 18. But the shortcut would be to go, from 6 to negative 12, I'm just going 18 units this way. So I could just, do the subtraction here and say, all right, 6 minus negative 12 is 18, and I'm going to the left, so that's 18 units left. But when I think of the ratio of 5 to 4, so this is also a little bit tricky to draw. But the ratio of 5 to 4, what it means, so let me just draw, we're going to have 1, 2, 3, 4, 5, 6, 7, 8 will make 9 equal. Let's just pretend all these little pieces are equal. But a ratio of 5 to 4 means I have 1, 2, 3, 4, 5 equal pieces this side, and then 4 equal pieces on this side. So that's why in the formula we add P plus Q. This tells me that I have 9 equal parts. And the location of point A is going to separate this big line segment into a ratio of 5:4. But I'm starting at R. But if I want 9 equal parts, what I'm going to do is divide this stuff by 9. And you'll see there's a point to this. So this would tell me to go down 1 and go to the left 2. So I start over here, I go down 1 to the left 2. Then I go down 1 to the left 2. And I keep repeating this. Down 1 to the left 2, down 1 to the left 2, down 1 to the left 2, here like this. And I keep doing this. And eventually I get to point Z. And notice I have 1, 2, 3, 4, 5, 6, 7, 8, 9 equal segments. And A is separating segment RZ into a ratio of 5:4. So that's 1, 2, 3, 4, 5. A would be located over here. So I'll just make this really stand out. It would be over here. And let's pick a better color. So here, green will really stand out. And notice this does match up with -4, 1. Okay, so the formula, of course, is way, way faster. But I do like to show this visual way because it starts to explain why the formula works. That I start at x1, which is the first letter of the directed line segment. And then I'm going a fraction of the way. So I'm going, if I have a ratio of 5/4, then when I go a ratio of 5/4, I'm going 5/9 of the way, which is why over here we're multiplying by 5/9. So this topic can be a little bit tricky, but I find if you commit to understanding the visual way, that you really, really understand this. But in either case here, we're going to get choice 4. Question 17, in triangle ABC below, points D and E are on AB and CB respectively, such that DE is parallel to AC. So we're starting off here knowing that these segments here are parallel. Then we have BD equals 9, DA equals 3, EC is equal to 4, and we want to know what is the length of BC. So that's this entire piece over here. So what we could do here is we could label BE with an X. And for this one, what I want to do is use the side splitter theorem. So anytime you have a triangle like this, let's say triangle ABC, and a parallel line is drawn through, and when I say a parallel line, I mean one that is parallel to one of the sides of the triangle. Well, when this happens, what we could say is the parallel line cuts the other two sides proportionally. So I could say AD over DB equals AE over EC. Now, with side splitter theorem, though, there's a very dangerous trap. Please, if they give you, let's say X was over here and 4 was over here, you cannot use the side splitter theorem. It only applies to the two sides actually being cut. So in this case here, we could use it, and we could say 9 over 3 equals X over 4. And now we could just cross multiply. 3X equals 9 times 4 is 36, which divide both sides by 3 tells us X equals 12. But be careful, choice 2 is a very dangerous bear trap, okay? It's very tempting. I say this phrase a lot. Sometimes students are so proud of themselves that they solve for X that they forget to answer the actual question. Okay, so the question was asking for the length of BC. So once you solve here and say X is equal to 12, then you have to do 12 plus 4 to get the total length, which is 16. So choice 4 is in fact our answer. Question 18, triangle ABC is mapped onto triangle A prime, B prime, C prime after a sequence of rigid motions. Which statement is always true? So for this one, we should know that a rigid motion is a transformation which preserves distance and angle measure. So what that means is when you do that type of transformation, the new triangle is going to be congruent to the original. So I'll just draw out a random triangle for ABC. So let's say I have this triangle here. And let's just say that for this one, I'll just name this randomly. I'll say this is A, B, and C. So what we could say for sure is that segment AB is going to be congruent to segment A prime, B prime, because when you have congruent triangles, corresponding parts of congruent triangles are congruent. So you can remember that phrase here, CP, CTC. Now, if you're not going to remember that whole phrase or the lettering here on how to do it, a fun way to remember this is I like to tell students, constipated people can't take craps. Now, don't actually write that at the Regents, but it'll help you remember that corresponding parts of congruent triangles are congruent. So AB corresponds to A prime, B prime, because you see how the letters are the same and they're in the same order here. So that's how I know it's 2 right away. No matter which rigid motion I do, those two sides are always going to correspond. And since the triangles are going to be congruent because we have a rigid motion, choice 2 will always be true. Now, why is choice 1 not necessarily true? Well, let's say I took this triangle here and I rotated it. So I just turn it this way like this, and I have A prime, B prime, C prime. Well, like I said before, AB is definitely going to be congruent to A prime, B prime. But since I rotated this, notice that these segments here are not going in the same direction. So they're not necessarily going to be parallel. If I did a translation, then yes, they would face the same direction. But we are not only limited to translations here. We could do any sequence of rigid motions. So we could rotate, reflect, or we could translate. Okay, so those are all fair game. The measure of angle A is the same as the measure of angle B prime. This one here is not necessarily true. If I made an equilateral triangle, then sure. But if I made a triangle where all three sides and all three angles are different, then these angles would not correspond. Okay, A does not correspond to B prime. A corresponds to A prime. And notice here, a triangle can have two right angles. So if A is a non-right angle and B prime has to be a right angle because it corresponds to B, then A would not be able to be equal to B prime here. So that's why this one is out. Now, this one's a little tricky to understand. The orientation of A prime, B prime, C prime is the same as the orientation of, we have triangle A prime. I'm sorry, yeah, the orientation of triangle ABC is the same as the orientation of triangle A prime, B prime, C prime. So a rotation will preserve orientation. What that means is, if I were to go, in this case, in a counterclockwise direction like this. So if I spin this way, notice that I'm saying, and let's say I just keep spinning in a circle like this. So I keep spinning like this, I'll just keep saying the letters ABC, ABC, ABC. And if I spin in that same direction like this, so also counterclockwise, notice that I keep saying A prime, B prime, C prime, A prime, B prime, C prime, A prime, B prime, C prime. So these two here do in fact have the same orientation, because when I spin, in this case in a counterclockwise motion, I'm saying the same letters in the same corresponding order. So ABC, A prime, B prime, C prime, like this. However, there is a rigid motion which does change the orientation, and that would be a reflection. So if I did a reflection of this triangle, so let's say I just borrow, so let me get this piece here out of the way. So now I'll just get rid of this. So if I take this triangle over here and I reflect it over, let's say, this line like this. So I do a reflection, then this point would go somewhere over here. This point would go, I don't know, maybe somewhere over here. And this one would go somewhere over here like this. And let me just make this neat. So I'll draw these line segments in. So my image would land somewhere over here. Okay. And this would be A prime, B prime, C prime. But now watch, this one would still be that counterclockwise motion. So if I change the colors here, in this counterclockwise motion like this, I would be saying ABC, ABC, ABC. However, if I go counterclockwise here, notice I'm saying A prime, C prime, B prime. I'm not saying A prime, B prime, C prime. I'm saying A prime, C prime, B prime. So the orientation changes. So 4 is out because the reflection ruins this. So definitely choice 2. Question 19, what are the coordinates of the center and the length of the radius of the circle, whose equation is x squared minus 16x plus y squared plus 20y equals negative 155? So for a question like this, what we need to be able to do is complete the square. So I'm going to write out that equation again, but I'm going to leave a little space after this x term. And then I'm going to write, we have y squared plus 20y. I'm going to leave another space after this and then say equals negative 155. And the technique, once again, I want to go with is completing the square. And you want to use this when you have a quadratic in the form of x squared plus bx. Okay, so when I say quadratic, that's just like an x squared type expression here. So we're going to have a 1 in front of our x squared, and we're not going to have a constant term at the end. So notice that we have this x squared x term and then the y squared y term. So what you want to do when you're completing the square is you want to find the b value and divide it by 2 and then square it. Okay, so that's what I'm going to do for these two things here. So our b value over here is negative 16. And if I divide that by 2 and square it, I'm going to get negative 8 squared is 64. And then that's the mystery number that we want to add to both sides. I'm going to go plus 64 on the left. And then I have to do the same thing on the right side, plus 64. And then for this one, I'm going to use that same idea. So this time I have a b value equal to 20. So I take half of it and then square that number. So half of 20 is 10, and then 10 to the second power is 100. And that's the number I'm going to add to both sides. Now, the reason why they call this completing the square is now what we wind up with are two perfect square trinomials. And what that means is when we factor, we're going to get matching factors. So here I'm going to take this, and I'm thinking about what two numbers have a sum of negative 16 and a product of 64. That's going to be negative 8 and negative 8. So we have x minus 8 times x minus 8. And now I have plus. I want to think about next what two numbers have a sum of 20 and a product of 100. And here what we're going to get is 10 and 10. So I'm going to write y plus 10 times y plus 10. And now all of this, so we'll just make a little space here, but all of this is going to be equal to, so we're going to have this is all equal to, and if I do 100 plus 64, that's 164 minus 155. And these numbers here are going to be 9 units away from each other. So I'm going to say this is all equal to 9. And now I can write this a little bit nicer. So this is x minus 8 squared, because I'm doing x minus 8 times x minus 8, plus y plus 10 squared equals 9. Okay, and once again, this is why we call these perfect square trinomials, is that we are able to factor them then into two matching factors like this and writing the equation in this form. But now what we need to know is the equation of a circle. So let me just get rid of this stuff over here so we have the space. But the equation of a circle, when you have center, so center HK, and then let me just make that a little neater. So if you have center H comma K and you have radius R, the equation of the circle is x minus h squared plus y minus k squared equals the radius squared. So here, what we're going to have from this is a center of positive 8 comma negative 10. We just take the opposite sign. See how it's x minus h plus y minus k in parentheses here, and both being squared. You just take the opposite to go back to the center. So the opposite of minus 8 is plus 8. Opposite of plus 10 is minus 10. And then the radius, we just have to be careful here. The radius, so our radius is going to be squared on the right side. So we have to take the square root of 9, and the square root of 9 is equal to 3. Okay, so now we just go looking for the answer here. So we have choice 3, center 8, negative 10, radius 3. Question 20, state populations and land areas from the 2020 U.S. Census are shown in the table below. Which list shows the state population densities in order from smallest to largest? So when I hear population density, first I just think density is equal to mass over volume. But when we're talking about population density, that's going to be, we're going to have the population, so population divided by land area. So it's really just how many people are there over a given land space. So that's how we find the population density. So I'm just going to make another column here and just call this density. Okay, this is the population density, but I'm just going to abbreviate it like this. I'm only going to write the word density. So let me just go ahead and do this. And I'm going to just continue the table here. So I'm going to find the population density for Connecticut, New Jersey, New York, Pennsylvania. We're just going to divide the population by its corresponding land area. So ready, we can start typing these in. We have 3,605,000 and then 944 divided by the land area is 4,842 square miles. Okay, so this would be our first population density, and it's going to be people per square mile. And then next we would have 9 million. So the population for New Jersey, we have 9,288,994 divided by 7,354. And we get this value here. And then next we have New York. There's 20,201,249 people, but over, so divided by a land area of 47,126 square miles. Okay, so that's this. And then Pennsylvania, there's 13,002,700 people over 44,700, and then we have 43 square miles. Okay, so these are the population densities. So I'm just going to round to the nearest whole number. So we have roughly 745 For Connecticut, then we have roughly 1,263, and then roughly 429, and roughly 291. So we're going in order from smallest to largest. So you see how Pennsylvania was the smallest, and right away choice 1 is matching that. But let's just check that everything else is correct. So smallest to largest, we have Pennsylvania, then we have New York, then we have Connecticut, and then we have New Jersey. So choice 1 is our answer. Question 21, line T is represented by the equation y equals 2x minus 1. If the line is dilated by a scale factor of 3 centered at the origin, which equation represents the image of line T after the dilation? So for this one here, the first thing that I check is I make sure that my center of dilation, which in this case is the origin, that's the point 0, 0, I make sure that the center of dilation is not on the line that we're actually dilating. So if I plug in here, this is the point x comma y. If I plug into this equation, I get 0 equals 2 times 0 minus 1. And that says 0 equals negative 1, which is not true, which tells us the center of dilation is not on this line. So we're going to get an answer that's different. So right away, choice 3 is gone. Now, the next big idea is that when you dilate a line, so a line dilation, the dilated lines, I'm just going to say dilated lines are parallel. Okay, so dilated lines are parallel, which means slopes don't change. Okay, so I'll just say same slopes. Okay, that's a very big idea. So this line over here, you see how the starting line that we're dilating has a slope equal to 2. Well, if the slope is equal to 2, that means the dilated line is also going to have a slope equal to 2. So now these two choices are out. And just by process of elimination, it has to be choice 1. But now let's actually see what's going on here. So when we have this line here, 2x minus 1, so that's, I'm starting here, this is our y-intercept of negative 1, means we're starting at 0, negative 1. And then I go up 2 over 1 like this. So if I have my line like this, and let me just extend this out also in the other direction here. Well, if this point on my line is over here at y equals negative 1, and I'm dilating with a center of 0, 0, scale factor of 3, so that's a k value of 3, I'm dilating every point on this line. But watch what happens when I dilate the y-intercept. So the y-intercept here is located at 0, negative 1. So if I dilate that point, so 0, negative 1, we dilate it, and we're going scale factor of 3, and our center is 0, 0. All that's doing is multiplying the x and y by 3, and we get x is 0 times 3 is 0, negative 1 times 3 is negative 3. And this tells us our new y-intercept for our dilated line is going to be, let's say this is over here at negative 2, is going to be at negative 3. And the new line is going to be, once again, parallel to the old one. So the slope is not going to change, but the position of the line is going to change. It's going to move out more, and its y-intercept is going to change here to negative 3. So now I have a line that has a slope, so let me just write m. So it has a slope equal to 2, and a b value here, a y-intercept equal to negative 3. So our new line is going to be 2x minus 3. Just remember this important equation here, y equals mx plus b. Remember, this value here tells you the slope, the m value, number in front of x, and this value tells us the y-intercept. Okay, so you could just draw this out and visualize it, but just with process of elimination here, we could also get choice 1. Question 22, quadrilateral ABCD is a parallelogram. Which additional statement is sufficient to prove ABCD is a rhombus? So for this one here, what I'm going to do is I'm just going to draw out a little sketch here of a rhombus. So that's a parallelogram with all 4 sides equal. So this one here, that's my sketch of a rhombus. So now let's just run through the answer choices. And I'm going to label this. It doesn't matter where I write my letters, as long as once I commit, let's say I put A here, that I either go in a clockwise or counterclockwise direction writing the other letters. So I could go A, B, C, D, or I could go A, B, C, D this way. All right, I can't do something like this. I can't go A and then B and then C and then D. I can't zigzag going over the diagonals here. I have to go either clockwise or counterclockwise. So A, B, C, D. This is fine. We could use this to represent our soon-to-be rhombus. Well, let's think about what we have here. AB is congruent to CD. This Like, think about this question as asking what would upgrade. We want to upgrade the parallelogram. So I'm going to say we're going to upgrade the parallelogram to a rhombus. Okay, so we're trying to upgrade. So when they say AB is congruent to CD, that is true for any parallelogram. Any parallelogram, opposite sides are parallel and congruent. So that wouldn't be something special, unique to just a rhombus. Okay, if I just draw any parallelogram that's like clearly not all four sides equal, the opposite sides though are always going to be equal. So one is out because that's nothing special. AD is parallel to BC. Well, that's once again true for every parallelogram. The opposite sides of a parallelogram are parallel. So that is not anything special here. So choice 2 is out. But now this one is something important. AD is congruent to DC. So if I just get rid of this one here like this, if I'm told that AD is congruent to DC, this is different. These are not opposite sides. These are consecutive sides. Okay, so if you are told that one pair of consecutive sides of a parallelogram are congruent, that will upgrade the parallelogram to a rhombus. And the reason being, if I'm told these two are the same, since this is, once again, already a parallelogram, so this is once again, a parallelogram. Sorry, this is like a little bit of a spelling bee here. So a parallelogram, if I know these two are the same, well, if we have a parallelogram, the opposite sides are congruent. So AD would have to be congruent to BC, and DC would have to be congruent to this. So now all four sides would be the same, and this would be the upgrade we need. And now let's think of this last one here. Why is this not sufficient to prove ABCD is a rhombus? We have angle ADC, so this angle over here is congruent to angle ABC. Well, opposite angles of a parallelogram are congruent. That is true. So this is true for all parallelograms. Okay, so I'll say this is true. So I'll just say these are all true for all parallelograms. Okay, and that includes parallelograms that are not rhombuses. So that's why those are not special. Choice 3 is our answer. Question 23, in right triangle ABC below, we have the measure of angle ABC is 90 degrees, and we have BD is perpendicular to ADC. Then we have if AD is equal to 3, CD is equal to 12, the length of AB is, so we want to find this piece over here. So for this question, there's a few different ways we could do this. We could do the altitude rule, or we could do the leg rule. But the leg rule here is going to be better because we're looking for the missing leg of this right triangle that we're starting with. Okay, so just make sure you don't skip leg day. So we have, this is leg 1. And then over here, this is part 1. This one, let me just actually clean that up a little bit. I'll write this in a better spot. So this, I'll just point off to the side here, is part 1. This one here is part 2. And then our hypotenuse, so the hypotenuse would be part 1 plus part 2 is 15. Okay, so this is going to get us started. Now, I just want to point out, we are going to use the leg rule here, but just know this is very important. When you want to use the leg rule or the altitude rule, it's very important that you start off with a right triangle and then an altitude is drawn from that right angle. Okay, so you could only use these rules when they tell you that you're starting off with the right triangle and the altitude is drawn from the right angle to the opposite side. So now let's go ahead and use the leg rule. So what we have is we're going to have hypotenuse over leg 1 equals leg 1 over part 1. Okay, let me just make that a little neater. So leg 1 over part 1. It helps to just know this rule. There are other ways around this question if you forget the formulas, but I do think this is like the most straightforward way. I'll show you what to do if you forget this formula. So I start off, the hypotenuse, the entire length of the hypotenuse of the big right triangle is 15. Over leg 1 is x, that's what we're looking for, equals leg 1 is still x, over part 1 is equal to 3. And now just do the algebra, we cross multiply, we get x squared equals 45. Take the square root of both sides, and then we look and we say, oh no, my answer is not there. And that's because we need algebra 1 skills. We have to break down square root of 45. And square root of 45 could be broken down to square root of 9 times the square root of 5. Now you might say, what about 15 and 3? Those are my favorite factors of 45. However, 15 and 3 are not perfect squares. You always want to choose factors where one of them is a perfect square. So now square root of 9 is 3, and we get square root 5. So our solution here is going to be x equals 3 square root 5. And this is what we were looking for, choice 3. Now, what do you do if you forget the formula? Well, if you forget the formula, the big idea for this is similar triangles, okay? Just know with similar triangles, corresponding sides of similar triangles are in proportion. So what I would do if I forget the altitude rule or the leg rule is I would draw the triangle separately here, but I would make sure that they're positioned facing the same direction so you can identify the correspondence. So just imagine here that I take this triangle, so this one over here. So I'm looking at this one. Imagine I take this triangle and I move this off to the side here. So I'm just going to move this over here. And then I rotate this thing on its side. So now I want to look at this triangle over here, the one that I'm highlighting in blue. So this one, I want you to imagine here, what I'm going to do is I'm going to flip it this way. So imagine I reflect this blue triangle over segment AC. So if I do that, now it's going to face, it's going to go this way like this. So I'm just flipping it like this. And then what I'm going to do is I'm going to rotate this so it's facing the same direction as the other one. So we'll just turn this and you can see now they are facing the same direction. But now what I have to do is I would have to label. So you see here, this short side here of this triangle, we have A over here, we have D over here, and we have B over here. Okay, and then AD is equal to 3 and AB is equal to X. And then for the blue triangle here, remember, I flipped this first. So I flipped it over this and then rotated it. So the right angle is at B. The shorter side is from A to B. And then here, the longer leg is from B to C. And now I could label AB is equal to X. And then AC, this hypotenuse, was once again 3 plus 12, which is 15. So now you see I have two similar triangles and their corresponding sides are in proportion. So for this, what I could do is I could say, let's say I do this leg here, 3, over this hypotenuse X equals this leg here, X, over this hypotenuse 15. And notice what I get X squared equals 45. And this is the same exact equation that we had before. So I just take the square root of both sides, and this is the same simplification. The square root of 45 simplifies to 3 square root 5. So I'm also getting choice 3 this way. Question 24, in triangle GBT, shown below, GXM, BXR, and TXE are drawn such that point X is the centroid. Which statement is always true? So for this one, we just have to know our vocabulary. The centroid is the point where all three medians intersect, and it does something very interesting to the three medians. It separates all of them into a ratio of 2 to 1. So let's say over here, I call this piece, since the letter X is taken, even though it's capital X, I'll put a lowercase y here. If this piece is Y, this piece is 2 times Y. And then let's say I go with the letter W. If this piece here is W, then this one would be 2 times W. And then let's say I'll do another letter. Let's say I go with the letter, I'll go with the letter Z. So if this is Z, then this piece over here is 2 times Z. So now we just run through the answer choices. MX, so you see how MX is Y? So I would have over here, I'm just going to point this out. This is Y over GX is 2Y, simplifies to 1 over 3. That's not true because when Y over Y cancels here, we're left with 1 over 2, not 1 over 3. This would be correct if I said MX. So this shorter piece over MG. Then this would work out to 1/3 because MX is still equal to Y if I'm just setting a Y here. And then MG would be Y plus 2Y or 3Y. And then we would get this to simplify to 1/3. But that's not what's written here, so 1 is out. And now we have, let's see, TX is 2Z divided by EX is 1Z. Okay, and then if we write a 1 over here, when Z over Z cancels, this equals 2 over 1. So choice 2 is our answer. But let's see why the other answer choices are no good. So BX is congruent to RX. This is not true. BX is twice as long as RX, so that one is out. And then we have TM is congruent to TR. Now, it looks like that's the case here, the way they drew this, but that wouldn't always be true if triangle, let's say this triangle here, let's say we have a scalene triangle. That would mean all three sides are different. And if all three sides are different, then these segments would not be the same. And the reason behind this, we have to know that the centroid joins, so it's the intersection I'll just say this here. This is the intersection of all three medians. And for this, we should know that the median, so another definition, the median is a segment that connects the vertex to the midpoint of the opposite side. So this connects the vertex of a triangle to the midpoint of the opposite side. Okay, so this is a very important definition to know. So connects the vertex and the midpoint of the opposite side. So really what I could say here, a little follow-up, is that these points here, so point M, point R, and point E are all midpoints of their respective sides. So I could say this segment is the same as this one is the same as this, and then this segment here, GE, is equal in length to BE. So here I can't say those two segments are the same because I can't say for sure that GT is exactly equal in length to BT. If this triangle were isosceles, then yes, this would always be true, but they didn't say the triangle was isosceles, so we can't assume this. So choice 2 is our answer. So now moving on to part 2, there's 7 questions here, and each question is worth 2 credits. Question 25, a triangle has vertices with coordinates 2, 1, 0, 3, and -2, -1. Determine and state the coordinates of the vertices of the image of the triangle after a reflection over the x-axis, followed by a translation of 3 units to the right and 2 units down. And then we have the use of the set of axes below is optional. So for this one here, I would just start off with 1 point at a time. So we have 2, 1. And what we're going to do first is we're going to reflect over the x-axis. Okay, so reflection over the x-axis. And if you know the formula for reflection over the x-axis, you just change the sign of the y. So we have 2, comma, -1. So we're going from +1 to -1. And then next we're going to translate 3 units to the right. So we have capital T. I put a 3, comma, 2 units down is -2. And for this translation formula, we just do 2 plus 3 is 5. And then we have -1 plus -2 is -3. But let's say we forget the formulas. What we could do is we could start by plotting the point 2, 1. So that's over 2 up 1. And we could actually reflect over the x-axis by ourselves using the graph. So we could count here, let's see, to the x-axis, that's 1 space this way. So then we go another space here like this, directly across. The x-axis will act as a mirror image. And then we go 3 units to the right and 2 units down. So that's over 1, 2, 3, and then down 1, 2. And let's see where the final location is from 0, 0. That's over 1, 2, 3, 4, 5, and then down 1, 2, 3. So you see, we still get 5, -3, but the graph is here just to help us out. So next we'll do, let's see, we have 0, 3. And if we reflect this point here over the x-axis, remember, we just changed the sign of the y value. So we have 0, and then instead of +3, we have -3. And then a translation of 3, -2, we're going to do 0 plus 3 is 3, and then -3 plus -2 is -5. And if I want to do this by hand, I start at 0, 3, so that's up here. I reflect over the x-axis, so I go an equal amount this way. And then I translate 3 units right, so that's to the right 1, 2, 3, and 2 units down. And notice that brings us to the point 3, -5. So this one also checks out. And now last, we'll do this with the point -2, -1. So we have -2, -1. First, we reflect over the x-axis. So we're going to leave the x coordinate alone, and we're going to change the sign of the y value. So instead of having -1, we're going to have +1. And now we translate 3 units to the right and 2 units down. So we just add 3 to the x coordinate. So -2 plus 3 is +1. And then 1 plus -2 or 1 minus 2 is -1. But once again, if you have the time at the Regents, you should absolutely use the graph to help you make sense of your answers. So we're starting at -2, -1. So that's over here. We reflect over the x-axis. So this time we're going up to the x-axis, and then we go up one more like this to bring us here. And then we go 3 units to the right. So that's over 1, 2, 3, and then 2 units down. And this does bring us to the point 1, -1. So these points here, I'll just circle these, are good. Okay, these are going to be the image of the 3 points. Question 26, a cylindrical bucket is being used to transport topsoil. The bucket has an inside diameter of 10 inches and a height of 15 inches. If the topsoil weighs 0.0231 pound per cubic inch, determine and state the weight of the topsoil in the bucket when the bucket is full to the nearest pound. So for this one, we're starting off with the information here that we have a cylindrical bucket, which means the bucket, if we sketch this out, is going to be in the shape of a cylinder. Now, if you go to the back of the Regents, the volume of a cylinder is pi r squared times h. And just know r represents the radius and h represents the height. And they told us over here the inside diameter is 10 inches. So if we have a diameter of 10 inches, that means we have a radius of 5 inches. So this is just information here to record. The height of the bucket is 15 inches. And once again, we want to know, determine and state the weight of the topsoil in the bucket when the bucket is full to the nearest pound. So first what we have to do is find the volume. And we're going to have volume equals pi times the radius squared times the height. Now, one thing I want to point out, you don't actually have to show the substitution with the units like I am doing now. But when I teach this stuff, I like to show the idea behind how the units cancel at the end. And plus, for a class like physics, the units are super important. So I like to show the substitution with the units. But if you just want to play it safe, don't write the units as you're doing the question. Just write the numbers and circle your numerical answer at the end. So now we would just have to type this in. So we have pi is second in this up arrow here, and then 5 squared. So we have 5 in parentheses squared, and then times 15. But now let's think about this logically. We have 1178, or I'll say 1178 point something something cubic inches of space inside this bucket. But they told us that the topsoil weighs this many pounds per cubic inch. Okay, so here what we're going to do with this information at the end is we're going to multiply by 0. And then we have 0.231. Okay, so we get this value here. Now, some students might make the mistake here of dividing by 0.0231 like this. But then ask yourself, does this answer make sense? Does it make sense if the weight of the bucket with the topsoil is close to 51,000 pounds? No. So please remember, common sense will get you very far in this world. You just have to, when you get answers in math, ask yourself, does my answer make sense? The 27-pound answer makes way more sense than 51,000 pounds. So now I'll just write this out. I'll say the volume equals, we have 1,178 and then 0.097245. And the units here, we have inches squared times inches is cubic inches. Now, the reason why I like to show the substitution with the units is so that it's very clear that we're going to be multiplying the volume by this density here. Okay, so we're going to be doing the mass here of the topsoil. So I'll just say, well, we just say here at the end the weight. Okay, so the weight, because they're saying determine and state the weight. So I'll say the weight equals, and we're doing 1,178. We have 0.097245 and then cubic inches, and we're multiplying this by, we have 0.0231, and then the units are pounds, which you could write as lb like this. Okay, so pounds per cubic inch, and then you see how the units cubic inches over cubic inches cancels out, and then this tells us that the weight here, so the weight, if we round to the nearest pound here, so to the nearest whole number, we're going to get 27 pounds. Okay, so I'll just say 27 pounds like this. If you want to write the actual word out, you can too. You could say 27 pounds, or you don't even have to write the units at all, but this would be an acceptable way to show our answer. Question 27, in right triangle SRT, the measure of angle R equals 90 degrees, the measure of angle S equals 27 degrees, and ST equals 31.8. Determine and state the length of SR to the nearest tenth. So for this one, I recommend that you just draw out a right triangle so that you could label it. You don't have to draw this to scale, but you should draw something so that you could plug in the numbers here. Now, they told us that R has to be 90 degrees. So the right angle, I have to label with R. But then the location of S and T doesn't matter. So let's say this one over here, I just call this S, and then this one here would have to be T. And they told us the measure of angle S is 27 degrees. Okay, so this angle here, I'm going to say is 27 degrees. So the measure of angle S. And then they told us the length of side ST is 31.8. So now what we want to find is we want to find the length of SR. Okay, so SR is this piece down here. So now we have to think of this phrase here, SOHCAHTOA. And we have to think about what we know and what we're trying to find. So we know that the hypotenuse is 31.8 units long. And I know this is the hypotenuse because it's across from the right angle. And then this is our angle over here. The 27 degrees represents our given positive acute angle. So x is the side adjacent. So I'll say, and I'll write out the whole word. This is the side that is adjacent to the 27-degree angle. So when you say the phrase adjacent hypotenuse, you should be thinking of the cosine function. And what I think of when I hear cosine is I hear cosine of theta is the ratio of the side adjacent, and not just adjacent to anything. This is the side adjacent to theta over the hypotenuse of the right triangle. So notice that in this case here, the given angle theta is 27 degrees and x is the one adjacent or right next to it. So now I just plug all of this in. I have cosine of 27 degrees equals the ratio of the side adjacent to 27 degrees is the one we're looking for, x, over the hypotenuse is 31.8. And now I could just call this cosine of 27 degrees over 1 and cross multiply, and we get x equals 31.8 times cosine of 27 degrees. And here they're telling us to round our answer to the nearest tenth. So we just type this in. We have 31.8, and we're multiplying that by cosine of 27 degrees. So let's just write in here 27. And notice we are in degree mode. So I always check that before I hit enter, just in case for some reason I switch the calculator over to radians. And we're going to get 28.3. So now I'll write out the answer more formally here. So the length of SR, I'm just going to say SR equals, and once again, we're rounding to the nearest tenth. So over here we have a 3 in the tenths place. To the right is a 3, which is less than 5. So we're going to round down to 28.3. And this is our solution to question 27. Question 28, in triangle LET below, LE equals 7.5, ET equals 9.3, and the measure of angle LET equals 115 degrees. And we have to determine and state the area of triangle LET to the nearest tenth. So for this one here, the formula that comes to mind is I think of the area of a triangle formula involving trig. So when I have a triangle like this, so let's say I call this triangle ABC, and the angles are capital A, capital B, capital C. The side lengths are lowercase a, lowercase b, and lowercase c, and they're opposite of their respective angles. There's a few different ways we could find the area of this triangle. We could say 1/2 AB sine of angle C. We could also say 1/2, and then I do, let's say, sides B and C, and then sine of angle A. Or I could say 1/2, and then I do AC times sine of angle B. So let me just go ahead and extend this thought here to fit all of this. So this is what I'm thinking for a question like this. But the big theme for this, I'm thinking side angle side. So the way I say this formula in words is I say 1/2, let's say the first one, the product of AB. So you see the product of sides A and B, and then sine of angle C is the angle between them. So say this to yourself a few times. You do 1/2 times the product of two sides times sine of the angle between. And where my head goes for this question is that angle E, so see here, angle E, which is 115 degrees, angle E is between, so this is between this side that is 7.5 and 9.3 units long. So for this one, I'll just say the area of triangle LET is equal to, I do 1/2 the product of the two sides, so I'm doing 7.5 times 9.3 over here, and then sine of the angle between them is 115 degrees. So now we just type this in, 0.5 we could write in place of 1/2, and then parentheses 7.5 times, in the other parentheses we have 9.3. We close it, and then we say sine of 115. And then this is going to give us our area. So the area here to the nearest tenth, we're just going to say is 31.6. Notice in the tenths place here we have a 6. To the right is a 0. So we're rounding down to 31.6. Question 29. A pool owner has a circular deck that surrounds her circular pool as modeled in the diagram below. The pool has a diameter of 24 feet. The distance from the edge of the pool to the outer edge of the deck is 8 feet. And we have to determine and state the number of square feet of the deck to the nearest square foot. So for this one, there's a lot going on, but what we want to think about here is a simple way to approach finding the area of the shaded region. So what I'm going to do is I'm going to do the area of, so the area of the big circle, so area of the big circle minus the area of the small circle. Okay, so that's really what's going on here. See, we have the big circle over here, so that's the entire circle here that covers all of this, pool and deck included. So we're going to find the area of this big circle, and then we're going to subtract the area of the smaller circle on the inside like this. And that'll tell us the area of whatever's left. So for this, the idea is area equals pi r squared. So what we could do first is say, all right, pi times, and I'll call these radii two different terms. I'm going to say outer radius for the big circle. So that'll be like, let me just write this a little neater. So r with the little subscript o. And then the small radius over here, I'll say r with the lowercase I for the inside radius. So inside radius and then the outside radius. But what we have to know here is if the diameter of the pool is 24 feet, this tells us that the inner radius here, so the inner radius is going to be half of 24. It's going to be equal to 12. Okay, and remember, we don't have to write units throughout, so maybe for this question, I'll just write out the numbers. So here, the inner radius is just going to be 12, in this case, feet long, but once again, we don't have to write the units throughout the whole question. And now, if the distance from the edge of the pool to the outer edge of the deck is 8 feet, that means that it's going to be 8 feet going all around. So if I put another 8 over here like this, we could see that the outside radius, so the outer radius is going to be 12 plus 8. Which is going to be equal to 20, okay? And this would be 20 feet. So for the area of the big circle, I am doing pi r squared, but I'm going to do pi times the outer radius is 20, and this is what we're squaring. See, the big radius here is 20, and then we have minus the area of the small circle. We're just doing pi times the inner radius is 12, and this is being squared. So now 20 times 20 is 400, so I have 400 pi, and then minus 12 times 12 is 144, and we just put the pi at the end. And for this one, we're going to determine and state the number of square feet to the nearest square foot. So we're just going to type this in and round to the nearest whole number. So we could just do 400 pi, so 400, and we press this second and then this up arrow here, and then minus 144 pi. So we have this, and to the nearest whole number, we're going to get 804. So we'll just write our final answer at the end to the nearest whole number. Notice we have a 4 in the ones place. To the right in the tens place is a 2. So we're rounding down to 804. The units would be square feet, but once again, we don't have to write them. We could just write the number at the end, so 804. Question 30, use a compass and straight edge to construct an equilateral triangle with AB shown below as one of the sides and leave all construction marks. So when you want to construct an equilateral triangle and you're starting off at the line segment, you want to first take the compass, you put the pointy part at one end, and you open it up so that the pencil goes to the other end. And then what I like to do is make a mark here to show that you measured the distance from A to B. And now I'm just imagining here the next point of the triangle is going to be in this neighborhood over here. So for this construction, I don't change the length of the compass at all, but I swing an arc over here in this direction in the neighborhood, once again, of where that third point is going to be. So now I actually move the compass, but I don't change the length of the compass. And I place this over here at the other end at point B. And now I swing the arc above like this. And notice that we have a point of intersection. And this tells us where the third point of our triangle is. And now all I have to do is just connect that point over here to A. And I connect that point also over here. So I'm just going to just draw in like this over here at point B. And this triangle over here would be equilateral. Question 31, in the diagram below, right triangle ABC is inscribed in the circle with right angle ABC. And we have to explain why AC must be a diameter of the circle. So for this one, the $1 million phrase is inscribed. So the fact that we have an inscribed angle here at point B, and the inscribed angle measures 90 degrees, this tells us that the arc that's intercepted by this angle is twice this much. So this arc over here, so I'm just going to highlight it like this, this arc would have to be 90 times 2. Okay, so we would be at 90. So I'll just make this neat. So 90 degrees times 2 is 180 degrees. Okay, so this is just helping us build our argument. I'm just going to fill out the picture here. And then remember the phrase, a picture is worth 1,000 words. Once we label the picture, that's going to help us write our sentence. So you see, if we have an inscribed angle of 90 degrees, the arc that's intercepted is going to be twice that. And since this segment here, AC, also intercepts that arc. So you see this segment over here is cutting the circle this way, and it's leaving a 180-degree arc, that tells us that AC has to be the diameter because AC is intercepting a 180-degree arc. Okay, just to summarize what we have here, the 2 points for this question is mentioning that angle B is an inscribed angle, and the arc that is intercepted here is 2 times that amount, which equals 180 degrees. And then the last part of this explanation needs to capture the idea that AC, this segment, also intercepts a 180-degree arc, which then leads us to the conclusion that AC must be a diameter of the circle. So now we're moving on to part 3. There's 3 questions here, and each question is worth 4 credits. Question 32, in isosceles triangle ABC below, AD is an altitude drawn to base BC. If the measure of angle BAC is 80 degrees and AD equals 8, determine and state the perimeter of triangle ABC to the nearest tenth. So for this one here, first let's go ahead and label. We have AD is equal to 8. And they told us the measure of angle BAC is 80 degrees. However, they told us also in the beginning that our triangle ABC is isosceles. So this part here, and they're telling us that the base is BC. So this information plus this information plus this information allows us to say that the 2 angles at the top are equal to 80 degrees divided by 2. So we have 40-degree angles at the top here like this. Okay, so we could just say here, with this isosceles triangle, if the altitude is being drawn to the base, then what's going to happen is the altitude is also going to bisect the angle at the top. And since we have an altitude here, so this phrase, we have an altitude, tells us that we have 2 right angles here at the bottom. So now trigonometry is fair game for us to determine and state the perimeter of our triangle ABC here. So what we want to do is we want to find each of these pieces that are left. So we're going to find, let's say, this piece over here. So BD, I'm just going to call this piece over here X. And then this piece over here, so maybe I'll call this one over here where AC is. So this one I'm just going to call Y, all right? But just know, like, if this piece is Y, then this piece over here I could also call Y. And then if this piece over here is X, then this one over here I could also label with an X. So now we're going to use trigonometry. So remember the phrase SOHCAHTOA. So for this, now we go ahead and get started. And let's say I want to solve for X first. So this 40-degree angle here, notice that X is opposite. Okay, so this side is opposite. And 8 is the side that is adjacent to the 40-degree angle. So when you say opposite adjacent, you should be thinking of the tangent function. So we could say tangent of 40 degrees is equal to the ratio of the side opposite of the 40-degree angle, which we labeled with X, over the side adjacent we labeled with an 8. Okay, and remember, we could only use SOHCAHTOA here because we're dealing with 2 right triangles. Okay, so when you have a right triangle, you could use SOHCAHTOA. So now I'm going to call this tangent 40 over 1. We cross multiply, and X is equal to 8 times tangent of 40 degrees. And I'll work this out at the end when we get everything set up so that we could just type everything all in at once. So we have this, and now I want to solve for Y next. So we just came up with an expression for X, or we have this equation here, but our expression for X is 8 tangent 40 degrees. And now we're going to do one for Y. So we're going to have next, when we're looking for Y, it doesn't matter which triangle I use, either one is going to get us the same result. But if I want to solve for Y, and let's say I go over in this triangle here because there's less clutter, Y is the hypotenuse of this right triangle over here. So you see the right triangle I'm focusing on. So this one, Y is the hypotenuse, and we still know the adjacent side. So when you say adjacent hypotenuse, you should be thinking cosine. So cosine of 40 degrees is equal to the ratio of the side adjacent to the 40-degree angle, which is 8, over the hypotenuse we labeled with a Y. Okay, so this piece is now what we're solving for. And for this one, you could use the nice technique here. You could just swap these two. So we could say that Y is equal to 8 divided by cosine of 40 degrees. All right, if we want to see the algebra off to the side, what I could do also is just say cosine of 40 degrees equals 8 over Y, and call this cosine 40 over 1. Cross multiply, and we get Y times cosine 40 degrees equals 8 times 1 is 8. And then just divide both sides by cosine 40 degrees. So you see that we get the exact same result here, but the swap technique is really nice. It just gets you right to where you need to be, okay? And this was, once again, to solve for Y. So we have, this is our equation for Y. and y equals 8 over cosine 40. But now, before we start typing anything in, the goal here is to find the perimeter. Okay, so the perimeter of triangle ABC, this part now we think about the perimeter. If we go all the way around, see how, and I'll just move up a little bit so we could see that we're going y. So we're going y, plus we go x plus another x. So we're really just doing 2y plus 2x. So that's what we need to set up here. So I'm going to say the perimeter. So the perimeter of triangle ABC, and this is just so we know what to tell the calculator, is 2 times y plus 2 times x. So that's going to be 2 times y is 8 over cosine 40. And then plus 2 times x, and x is 8 times tangent 40. Okay, so this is what we're going to type into the calculator. So we could just do this over here. We have 2 parentheses, and I could just press alpha y equals enter to pull up a blank fraction. If you have a newer calculator, you could just do 2 times parentheses and press alpha x to pull up a blank fraction. And we have 8 over cosine of 40 degrees. And now I close this, hit the right arrow to get out of the fraction, close the entire fraction, and then plus 2 times parentheses. And then next we have 8 tangent 40. Okay, so 8 times tangent of 40 degrees. Okay, so just make sure, I'm just double checking that we typed everything in nicely here. And I'll just go ahead and put that last parenthesis to close it around this. Press enter. And this tells us our perimeter to the nearest tenth is going to be 34.3. So we'll just write this out. The perimeter equals 34.3. And this is our final answer. Question 33, in quadrilateral SMIL below, diagonals IS and ML intersect at point E. MS is parallel to IL and MS is congruent to IL. And we have to prove that triangle MIE is congruent to triangle LSE. So I'm just going to highlight here so we could focus on which triangles we're trying to show are congruent. So we have this one here and this one here. These are the triangles we're trying to show are congruent. So what I like to do for questions like this is just transfer the givens over to the diagram. So we were told that MS is parallel to IL. Okay, so these segments here are parallel and they are also congruent. So now the first thing that goes off in my head is I want to say that this quadrilateral SMIL is a parallelogram because one pair of opposite sides are both congruent and parallel. And then once we know we have a parallelogram here, we could say that these pair of sides here are the same. So these two are the same. We could also say that these two segments are parallel. And then once we have parallel lines on the triangles we're trying to show congruent, then we could start saying things here like alternate interior angles are congruent. So I could say this angle here and this angle here are congruent, and then this one over here and this one over here are congruent. And I could say these two triangles are congruent by the angle side angle postulate. Okay, so that's where my head goes. The first thing that we have to do, though, is we have to write our first statement. And for the statement and reasons here, the first statement you always have to write is the givens. Now, just know writing this out on its own doesn't get you any points, but if you leave this out, then you will lose a point. So now let's go ahead and say next that we have SMIL is a parallelogram. Okay, so SMIL is a parallelogram. And what you could do is when you want to write parallelogram, you can abbreviate it like this. I just draw a parallelogram and write the letter, a capital P in here like this. And our reason for this, how do we know this is true? Well, because if a quadrilateral has one pair of opposite sides that are both congruent and parallel, the quadrilateral is a parallelogram. So now that we have this part here mapped out, what I could say next is I could say that the pair of sides now that are congruent and parallel in these two triangles, I could say over here that MI, so this side over here, MI, I'm going to say is congruent to, and I'll just say SL over here like this. Okay, so MI is congruent to SL. And I could also say in the same statement here, not only are these sides congruent, but they are also parallel. So it's just very important that you say every single thing, you spell it out here. Okay, it's not enough to just say, all right, this is now a parallelogram, so I assume these sides are the same. I actually have to state this. So we're going to say over here that MI So this side here is congruent to SL. And I could say that MI is parallel to SL. And the reason is opposite sides of a parallelogram are congruent and parallel. So next what we could say is, and I'm going to go ahead and label these angles over here. So this angle I'm going to put a 1, and this angle over here I'm going to put a 2. And then the one with the double marks here, so this one over here I'm going to put a 3, and this one I'll go ahead and put the number 4. So I'm doing this because when I want to say angles are congruent, I like to show students to label the angles with a number. That way we could say something like this. I could say that angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. Okay, so this is just a nice way to abbreviate. And what we're going to say here is that when parallel lines are cut by a transversal, the alternate interior angles formed are congruent. That's why, though, before I write out the reason for 4, it was so important over here that before I write out my statement 4, that I actually established, even though it's obvious, but I actually have to establish that MI is parallel to SL. You cannot say alternate interior angles until you establish that the lines building them are parallel. Okay, so now we're ready to close out this proof, but I just want to think about what we need to show here just to establish that we are ready to write our conclusion. So our goal from the beginning was to use the angle side angle postulate. And notice over here that we said that sides MI and SL are congruent. So over here, this was from saying MI is congruent to SL. And then for one pair of angles, I said angle 1 is congruent to angle 2. And then the other pair of angles inside the triangles are angles 3 and 4. Okay, so angle 3 is congruent to angle 4. So I made all 3 congruent statements that I need to in order to use the angle side angle postulate. So now I could just go ahead and write the conclusion now and say that triangle MIE, so this triangle is congruent to triangle LSE. Okay, and the reason, I'm just going to say angle side angle. Question 34, a solid glass trophy is composed of a rectangular prism and a rectangular pyramid as modeled below. The rectangular prism has a length of 12 centimeters, a width of 6 centimeters, and a height of 3 centimeters. And then we have the height of the pyramid is 10 centimeters. If the density of the glass is 2.5 grams per cubic centimeter, determine and state the mass of the trophy in grams. So for this one, we have to know the formulas for the volume of a rectangular prism and the volume of a pyramid with a rectangular base. So the volume of a rectangular prism is equal to length times width times height. And for the next one here, the volume of a pyramid. So the volume of a pyramid, and I'm just going to point out here that this is a rectangular base. So a rectangular base, this formula is going to be 1/3, and then we have times the length with height. Okay, so 1/3 times length times width times height. So these are the two formulas that we need. And what we could do first is find the volume of the rectangular prism. And they told us the length is 12 centimeters. We have 12 centimeters times the width is 6 centimeters. And then times the height is 3 centimeters. So this is for the rectangular prism. And for this one, we just multiply this out. So here I would just do, I could do this in the calculator, but we could just do 12 times 6 is 72. 72 times 3 is 216. So we get 216. And then centimeters times centimeters times centimeters is centimeters to the 3rd power, but we say cubic centimeters. So then next we have the volume of the pyramid part. So the volume of the pyramid with the rectangular base is 1/3 times, and for this one, we were told the height of the pyramid is equal to 10 centimeters. So first I want to point out the height of the pyramid is the distance going from here straight down to the center of the rectangle here at the top. And the height here is, once again, 10 centimeters. This is the height, once again, of the pyramid. And I should point out also that the height of the pyramid forms a right angle with the bottom like this. Okay, so we would have a right angle over here, but I don't actually have to draw that in. So now I just go back to this. So I have 1/3 times the length of the pyramid is 12 centimeters. So I have 1/3 times 12 centimeters times the width is the same as the width of the rectangular prism, which was 6 centimeters. So we have times 6 centimeters But now this is where things are different. The height of the pyramid is 10 centimeters, not 3. So we have times 10 centimeters. And now for this, once again, we could just use a calculator or just work this out. So 1/3 of 12 is 4. 4 times 6 is 24. And 24 times 10 is 240. So I have 240, and then centimeters times centimeters times centimeters is cubic centimeters. So now we could find the total volume. So if we just do the sum of these numbers here, so we just add this up, 6 plus 0 is 6, 1 plus 4 is going to give us 5, and then 2 plus 2 gives us 4. So we'll just say next, our goal is to find the mass of the trophy, but I'll just say that the total volume, so first I'll find total volume, is equal to 216 plus 240, which is 456 cubic centimeters. So now for the mass, I'll just say the mass is equal to, I take 456 cubic centimeters, and this is why I like to write the units, and I multiply it by this value over here, the 2.5 grams per cubic centimeter. So I'm doing times 2.5 grams per cubic centimeter. Okay, you see how the units cancel out very nicely like this. Now, what you could also do, though, is refer to the formula that, in general, density is equal to mass over volume. So if I want the mass, I just cross multiply. The mass is equal to the volume times the density. Okay, so I just multiply volume times density, and that also gets us our answer. So now I just do 456. You can just type this in a calculator, times 2.5 is going to give you 1,140, and the only unit left is grams. And this is our final answer. So now we're moving on to part 4, the final boss. There's only one question here, and this question is worth 6 credits. Question 35, quadrilateral ABCD is graphed on the set of axes below, with vertices at coordinates A, -3, 1, B, -3, -7, C, 6, 5, and D, 0, 5. And then we have segment EF is graphed with endpoints at coordinates E, -3, -3, and F, 3, 5. And we have to first prove that ABCD is a trapezoid. So the new and improved definition for a trapezoid for New York State is a trapezoid is a quadrilateral with at least one pair of parallel sides. So that's what we have to say when we make our statement that ABCD is a trapezoid. But first, what I would do is just look for the pair of sides that definitely are parallel here. And just from the graph here, it's very obvious that the parallel sides of the trapezoid are going to be AD and BC. But the way that we have to prove this, so the $1 million word here is prove, is we show that the slopes of these line segments are equal. And once we know the slopes are equal, that tells us that these segments are parallel. So let's go ahead and find the slope first of segment AD. So I could say lowercase m, and I write a subscript AD like this, and that means the slope of segment AD. And for this one, the formula that I'm thinking of is slope equals y2 minus y1 over x2 minus x1. Or I could even just count the rise over run. So here I could just go up 1, 2, 3, 4. So I'm rising 4 and then going over 1, 2, 3. See, I'm going up 4 over 3. So I know this is going to work out to 4/3. But let's say you don't like counting the rise over run. If that's too confusing, then what you could do is use the formula y2 minus y1. So what I do here is I subtract the y values first, and then I divide by the difference of the x values. So we could just go ahead and do that. So I have y2 minus y1, so 5 minus 1, divided by 0 minus -3. And then this gives us 5 minus 1 is 4, over 0 minus -3 is 3. Now, we know these are the ones that have to be parallel. So if we go to find the slope of BC, and let's say we mess up and we just, add or subtract wrong, please make sure that your number matches this, because you don't want to say like, oh, actually it doesn't work out, so you're wrong. Like, please know, when they tell you to prove something, they're telling you that it's true, and you have to show it's true. So next, now we have BC. So I'm going to focus on the x coordinates here, so these, and then we have the y coordinates. So let me just change colors here. So these y values here are what we're focusing on. So I could just use the formula again. So y2 minus y1. So I'm doing 5 minus -7 divided by, and then we have 6 minus -3. Okay, so we subtract. 5 minus -7 becomes 5 plus 7, which is 12, over 6 minus -3 is 9. And then if I reduce this fraction, just divide top and bottom by by 3, I get 4/3. Okay. And I'll comment here like, hey, these are equal. I like to use like kind of like a flowchart way of explaining this. So I first comment that these are equal and then say, all right, the implication here, I'll say like equal, I'll even say equal slopes. And this will tell us then that AD, that segment, is parallel to BC. So now we can write out our conclusion. So I'm going to say that ABCD is a trapezoid because it has at least one pair of parallel sides. Now, just want to point out, let's say this fraction part here was a little bit stressful. You can just do alpha y equals enter and pull up the blank fraction here and go 5 minus 1 over 0 minus negative 3. I could put negative 3 in parentheses. Just make sure when you do subtract, you use this one, and negative, you use this one. So I press enter, and then I press math, enter, enter, and it makes the answer into a fraction. So if I do it for the other one here, the 5 minus negative 7, so I have this, and I'm dividing by 6 minus negative 3. For this one here, I could also press math, enter, enter to get to 4/3. Okay, so I don't have to be able to do this stuff by hand. The calculator is a very useful tool. So for the next part of question 35, we have to use coordinate geometry to prove that segment EF is parallel to segment AD and BC. So for this one, I'm just going to go back to the beginning of the question here. So I'll just write this down. But E was located at -3, -3, and F was located at the point 3,5. Okay, so this was the locations here for E and F. And what we also found in the previous part here, so this I'll actually just, zoom back to what we just found a moment ago in the first part, was we found that the slope of AD, so the slope of AD was equal to 4/3, and the slope of BC, so the slope of BC was also equal to 4/3. So in this part here, if our goal is to show that EF is parallel to AD and BC, we want to show that the slope of segment EF is the same as the slope of the other segments. So let's go ahead and find that. The slope of segment EF. For this, I'm just going to do the difference of the y value. So y2 minus y1. I'm doing 5 minus -3. And I'm dividing by the difference of the x values, 3 minus -3. And for this gives us 5 plus 3 is 8 over 3 minus -3 is 6. And when I divide top and bottom by 2 here, or reduce, I get 4/3. So now what I want to point out is all three, these are all equal slopes. And the conclusion we could draw from this, so this proves then, we could say therefore, and I want to point out a nice symbol here. This cool symbol means therefore. So I could prove now and say therefore EF is parallel to AD and EF is parallel to BC. Okay, so they told us to prove that EF is parallel to AD and BC. So I'll just say this as two separate things here. I'm going to say EF is parallel to AD and EF is parallel to BC. And the justification here is we show that all three segments here have equal slopes. So EF has the same slope as AD and BC, which allows us to write this conclusion. So first, I just want to look at some information from earlier in the question. So we have the coordinates of all of these points here, and we have the graph from before. So when they say use coordinate geometry, there's a few different ways we could do this to justify this equation. We could use the distance formula, which says the distance between 2 points is equal to square root of x2 minus x1 squared plus y2 minus y1 squared. So we could use this formula, or we could use the graph and just use Pythagorean theorem. But let's say first that I use the formula. So let's say I want to use it to find the length of BC. So I'm going to say BC, which is, notice over here and here, is, and I have the coordinates here for B and C, is equal to the square root of, and now I'm doing, this is the difference of the x values. So I'm doing 6 minus -3 squared plus, and now I have 5 minus -7 squared. See, I'm going to subtract here 5 minus -7 and then square it. So BC is equal to the square root of, this is going to give us on the inside here, and I could use a calculator for the inside, but I have 9 times 9 is 81. And then plus, we have 12 times 12 is 144. and then this gives us BC is equal to, and if we work this out, 144 plus 81 is going to give us 225. And the square root of 225 is equal to 15. This actually works out to a perfect square. And the reason behind this, so there's like a little SAT math here, is when you have a triangle like this, 3, 4, you could say the hypotenuse is 5. This is a Pythagorean triple, 3, 4, 5. And it looks like if I were to extend this all the way down like this, that see how I could kind of turn all of this into a right triangle? That the big right triangle would be similar to the small one. It's just a scaled up version here. And it looks like, in a way, if I use the dilation language, it would be a dilation of 3. So if this side gets multiplied by 3, this side gets multiplied by 3, and the hypotenuse 5 gets multiplied by 3 to make 15. Okay, or just use the distance formula. That's also okay. So then next, what we have over here, EF, I'm just going to take a guess here and say that's going to work out to 10 using the similar triangles concept, but let's actually show the work. So EF, now for this, I could show equals the square root of, and now I'm focusing on these 2 points here. So I do the difference of the x values. So x2, I could say is 3, minus x1 is negative 3, and then we're squaring it, plus the difference of the y values, I have 5 minus negative 3, which is being squared. So then EF is equal to, I have the square root of, this is going to give me 6 times 6 is 36, plus on the inside I'll get 8, and then squared, 8 times 8 is 64, which gives us the square root of 100, and 100 is a perfect square. It works out to 10 when we take the square root. But now let's say I want to use the graph to find the length of AD. What I could do is I could count the rise over run here and show, okay, so the rise over run, I'm going up 4 over 3. So I could say off to the side using the graph, so over here, I'll say that AD squared, and notice that AD is the hypotenuse of this right triangle, but AD squared equals 4 squared plus 3 squared. So I don't have to use the distance formula. I could use the graph in Pythagorean theorem, but that's actually how we prove the distance formula, is by doing the Pythagorean theorem on the xy axis. So this tells us that AD squared is equal to 16 plus 9 is 25. And now the square root of both sides tells us AD is equal to 5. So now is this equation true? So is this EF equal to 1/2 the sum of these two? So now I just plug in. So EF we found is 10. And we'll see, is 10 equal to 1/2? So let me just make that a little neater. So is 10 equal to 1/2? The sum of AD is 5 plus BC is equal to 15. And now let's see what this works out to. This tells us 10 is equal to half of 20, which gives us 10. I'm going to make that neater. 10 equals 10. So we'll just say yes. Okay, so this one, so yes. This one here checks out. So is this, I'll even write it up here too. So yes, it checks out. And our justification involves coordinate geometry, where we could use the distance formula or we could use the graph and use the Pythagorean theorem.